Howdy ho, Math 1 students. The second video is on two I can statements put together. It benefits to put these together because they kind of go hand in hand. The first I can statement is simplifying expressions by raising a power to a power. The other one is simplifying expressions by finding the power of a product, right? So when we go ahead and look at this, and we talked about before what an exponent is and how we expand them out. So if I expand the expression using the definition of an exponent, this would be written as x times x times x, right? This would expand to y times y times y. So basically, whatever this base is, we multiply it by itself to the number of times the exponent shows. So when I look at this, when I go to expand this, right, this would be x to the fourth times x to the fourth, because x to the fourth all to the second gives me that. And now I can expand it further like this. So now when I look, right, now this whole expression can be simplified to x to the eighth power. Okay, and if I look at the next one, right, y to the third times y to the third times y to the third times y to the third. Now, if I expand this out, I have y times y times y, and I can keep going here, right? So I expand all four of these y to the thirds out to get this. And if I were to write this using one simple exponent, right, how many y's do I have here? If I count them up, I have 12. So this would be equivalent to y to the 12th. So now when I look, right, why would we want a shortcut? Because if I get to real high exponents, I don't want to expand it all the way out. So what would this shortcut be? Well, if I look here, how could I use 4 and 2 to get 8 and 3 and 4 to get 12? Well, what I notice is if I multiply 4 and 2, that gives me 8. If I multiply 3 and 4, that gives me 12. So the shortcut way to do this would be, if I had to, simplify x to the 12th to the third, I would just multiply those exponents, right? So if I had y to the 9th to the 8th, right? Expanding that out would be really crazy. So right away, I know I could just do y to the 9 times 8, which would be y to the 72, power of 72. Okay, so right away, when we look at it, the properties we're learning here, power to a property, power to a power property, means if I raise a power to a power, I'm going to multiply the exponents. But now when I have a product of different bases within this quantity raised to some power, I know right away I could just raise each of these to that power of t by multiplying them. So it would be m times t, and then y to the n times t. Okay? So let's look here. Right away, the simple problems that we're going to get, right, is examples 1 through 4, right? Just raising these powers to a power. So right now, everything in this quantity is going to be raised to the third power. So easiest way to simplify this, a to the 4 times 3, which is a to the 12th power. Now, number 2, right, when I look at that, right, everything, you got to remember, all of this is in parentheses raised to the 4th power. So we're basically going to do x to the 5 times 4, y to the 3 times 4, z to the 2 times 4. And if I simplify that, we would get x to the 20th power, y to the 12th power, z to the 8th power. Okay? Example 3, when everything gets raised to that second power, now we have to take that 6 and raise it to the second power. X to the 1 times 2, y to the 5 times 2. Now, 6 squared is going to give me 36, x to the second, y to the 10th. And we are done. Now, example 4 here at the end, right, when I look at it, everything in here is being raised to what power? The third. So negative 4 to the third power. Now, I multiply all these exponents. 5 times 3, b to the 3 times 3, c to the 2 times 3. Now, negative 4 to the third power, you have to remember, is the same as negative 4 times negative 4 times negative 4. And this will give you positive 16 times negative 4 is negative 64. So this would simplify to negative 64, a to the 15th, b to the 9th, and c to the 6th. Okay? Now, when we talk about like all of these, multiple step problems, you could actually combine both these properties to solve more intense problems, like the ones in 5, 6, and 7. So let's take a look here. When I look at example 5, right, first thing I have to do is simplify this, right, by raising everything to the second power. And the second step is to simplify this, right, raising everything to the third power. So right here, this is going to become x to the 3 times 2, y to the 2 times 2. Then everything here would become x to the 4 times 3, y to the 5 times 3. So all together, right, now I would get x to the 6th, y to the 4th, times x to the 12th, y to the 15th. But if you look, I have x's that I can multiply, and I have y's that I can multiply. When I multiply these x's now, when I multiply same bases, right? When I multiply same bases, what do I do with the exponents here? I add them. So I would get x to the 6 plus 12, which is x to the 18th. Then I would do y to the 4 times y to the 15th, which will give me y to the 19th. And I am done. Okay? So remember, we always look to get rid of powers to powers. Then we multiply same bases. So here, everything gets raised to the third power. So 3 to the third power right away is going to be 27. X to the second to the third is x to the 2 times 3, which is x to the 6th. Then it's y to the 5 times 3, which is y to the 15th. This quantity here is not being raised to any exponent, so we're going to have times 2x to the third y. So next, I'm going to multiply 27 times 2, which is 54. Then when I multiply my x's, x to the 6 times x to the 3, this is a step where I go ahead and I add the exponents. X to the 6 plus 3 is going to give me 54x to the 9th. Then y to the 15 plus 1 is going to give me y to the 16th. And I am done. Okay? Now, here, everything in the first quantity is going to be raised to that fourth power. Everything in the second quantity is going to be raised to the second power. Right? Do me a favor, try this problem, and then come back and check your answer. So, 2 to the fourth power, that's going to give me 16. A to the 4 to the fourth is going to give me a to the 4 times 4, which is 16. B to the third to the fourth is b to the 3 times 4, which is b to the 12th. C to the second to the fourth is c to the 2 times 4, which is 8. Now, negative 3 to the second power is negative 3 times negative 3, which is going to give me positive 9. A to the second is a to the fourth. B to the third to the second is b to the 6th. Then c to the second. Well, now I can go ahead and multiply my coefficients. So 16 times 9, right, is going to give me 144. And now when I multiply same bases, a to the 16th times a to the 4th, I'm going to go ahead and add the exponents to get 20. B to the 12 times b to the 6 is b to the 12 plus 6, which is b to the 18th. Then c to the 10th power. And I am done. Down below, we have these examples where we have to evaluate the expressions, right? So it does benefit to have a calculator for these. And remember, you could always use the calculator. And there's many different ways to do this, right? For me, I could plug this in the calculator exactly the way I see it, right? Or I can kind of simplify in my head, such as I would look at this as being 2 to the 3 times 4, which is 2 to the 12th power. And now if I go to my calculator, 2 to the 12th power will give me 4,096. Another way I could approach a similar problem, if I have 2 to the 3rd to the 4th, I know 2 to the 3rd is 8, and 8 to the 4th power, 8 raised to the 4th power, you would get the same answer, right? So 4,096 is what it simplifies to. I could also, in my calculator, open parentheses, 2 to the 3rd, close parentheses. I got an arrow to the right to get out of the exponent. Then raise that to the 4th, and I would get my answer. Now, me, it's easier to simplify and then go to the calculator. So here, I would read this as 3 to the 4th power, in parentheses, times 2 to the 6th power. So I'm going to go 3 to the 4th power times, I got an arrow to the right to get out of the exponent, times 2 to the 6th power. And right away I would get 5,184. All right, over here, I would get -2 in parentheses, multiply these exponents and get 6. And right away, I have to put the -2 in parentheses, raise it to the 6th power, and I would get 64. Okay? Now, the last one here, it says, rewrite 64x to the 4th, y to the 8th, using properties in reverse order. Well, think about it. What could I raise to some power to get this? Well, right away, 64 I know is the same as 8 to the 2nd. So if I write 8 here and I put an exponent 2 on the outside, I'm going to ask myself, x to what power to the 2nd would give me x to the 4th? What could I raise that x to? Well, I would multiply the exponents here. So 2 times 2, so that's going to be x to the 2nd will give me x to the 4th. Then y to what power of 2 would give me, or y to what power raised to the 2nd power would give me 8. Or y to what power to the 2nd power would give me y to the 8th. Well, what times 2 would give me 8? 4, so y to the 4th power. So this is equivalent to 64x to the 4th, y to the 8th. Hope this helped. Let us know if you have any questions.